and welcome to the arithmetic walkthrough for test 27. Let's get straight on with this one. So first of all, I've got a number, take away 7 equals 70. So the children know as soon as we have a missing number question, we're usually looking to use the inverse operation or the opposite operation. So I'll keep the same two numbers, 70 and a 7, but this time instead of subtracting them, I add them to get the answer of 77. Now, if I fill my missing box with that, does it make sense? Does it work? If I've got 77 and I take away 7, do I end up with 70? Yes, I do. For number 2 here, I've got half of 220. So the children can either use bus stop division. How many 2's go into 2? 1. How many 2's go into 2? 1. How many 2's go into 0? 0. Or they can write 220 and then we can, using our place value knowledge, we can half each place. So half of 200 is 100. Half of 20 is 10. Then half of 0 is nothing. So we add them together to get the same answer. For number 3, just a really straightforward multiplication question. Write them out if you need to. 4 lots of 3 or 3 lots of 4. We've got 290 divided by 10. I'll show you the proper method to do this a little bit later on. But for the time being, the children know that if a number's got a 0 on it and we're dividing it by 10, we can just cross that 0 out to get an answer of 29. The children know that what's actually happening is we're making that number 10 times smaller, but I'll show you that one a little bit later on. For number 5, then, I've got 1/5 plus 1/5. The rule when we are adding or subtracting fractions that have the same denominator is that we keep the deep down denoms the same and we just mess around with the numerators. So 1 plus 1 equals 2. For number 6, then, I've got 440 take away 40. Well, I'm not even going to go into this one because we can see there's 40 there and I'm taking 40 away. So 440 take away 40 is just 400. For number 7, then, a little bit like the one above, we have got a number here, 47, and we can cheat a little bit because we're making it 100 times bigger. What we actually do is just take both those zeros and put them on the end there. Again, the number is getting 100 times bigger, so on a place value chart, you would move that 47 2 times towards the bigger columns to the left. But because this one isn't a decimal, it's an easy one, we'll cheat. And I'll show you a little bit later on the proper way to do that one. 6 times 7 is 42. If you're not sure how to do that one, I tell the children to understand that 7 is split up into a 5 and a 2. So we could do 6 times 5, 6 times 2, and then add it together because 6 times 5 and 6 times 2 is much easier. So it'd be 30. That's a terrible 3. So 30 plus 12 would give me 42. And for number 9, then, I've got 50 times 40. Now, again, we can cheat a little bit. We can take those zeros off to make each number 10 times smaller and look at it as 5 times 4 is 20. And then I make it 100 times bigger, or I just put those 2 zeros back on. And there's my answer, 2,000. For question 10, I've got 0 times 30, which is essentially saying if I've got nothing, what do I have? If I have 30 times nothing, well, I've got absolutely nothing. If you times anything by 0, you have nothing after it. 12 times 6, then, if they know their 12 times tables, fantastic. If they know their 6 times tables, great. But like with the 7 before, we can understand that 12 is made up of a 10 and a 2. So if we do 10 times 6 and 2 times 6, we would get 60 and 12, add them both together to get to 72. For number 12 here, I've got 57 out of 10 is the same as or equal to something out of 100. So if I write this one as we would usually see fractions, if it wasn't on a computer, it would be 57 tenths. So we should already be thinking here, I've got a bigger numerator than his denominator. So my answer is more than a whole or more than 1, because 10 tenths would be a whole. But when we're looking at equivalent fractions, we're looking for a relationship between the two denominators of these numbers. So if I've got 10 on one side and 100 on the other, I need to ask myself, how can I change a 10 to 100? Now, you could argue you could add 90 to it, but when we're dealing with fractions, especially equivalent fractions, we are looking at a multiplicative or a division relationship. So either times or divide. So because it's getting bigger, it's a times relationship. What do I need to times 10 by to get to 100? Well, I need to times it by 10. Now I've figured out the rule. I use my golden rule with equivalent fractions, and that is whatever I do to the bottom, I do to the top. So if I'm times it by 10 at the bottom, I'm times it by 10 at the top to get an answer of 570 using that zero trick that we did earlier on. Here we go. I've got 8/16. I'm taking away 1/16, so I keep my deep down denom the same, and I just do 8. Take away 1, which would give me 7. For number 14 then, I've got a missing number question again, so I can use my inverse operation again, division. So I would do 32, keeps doing that, divided by 8. And essentially when you're dividing a question, you can share 32 out between 8 if you want to, but the children know that we are just asking ourselves, how many times does the smaller number go into the larger number? So you can count in 8s. Make a list if you need to. 8, 16, 24. And if you've forgotten, you use your fingers to count on 8 more. So 32 would be my answer. How many times have I counted 32? 1, 2, 3, 4. Once we've got our answer in, we check it. 4 times 8 is 32. Is that right? Does that sound right? 8 times 4 is 32 because we can do it either way around. Does that sound right? Number 15, I've got 416 times 1, or one lot of 416, so that would just be 416. And here we have the question where we can't take away a 0, so let's look at how we actually divide a number by 10 or 100, or times a number by 10 or 100 or 1,000. So first thing I'm going to need is a place value chart, so 10s and 1s, and then we've got our tenths and our hundredths. Children use place value charts all the time. They'll know what those are. So the first thing we need to do is put the original number in, and that is 1 in the 9s column. Now, because we're making this number smaller, we're dividing it, we're trying to push those digits towards the smaller columns. So it's going to go this way. And how many times we do it? Well, we've got 1 0, so we move it once. So instead of it being 9 1s, we end up with going this way, 9, coming over here, it ends up here instead. We end up with 9 tenths instead. Oops. So the answer can be 0.9, or the children sometimes used to showing that there's no 1s there, so you put 0.9 or 0.9. If I was doing it the other way, I would just move them the opposite direction. For number 17, I've got 472 hundredths equals what as a decimal. So for this one again, a place value chart is really, really useful. As I said before, because we've got a higher numerator than a denominator, it means that we've got more than 1. Okay, so these are the 1s. Really difficult to draw or write on this one. These are the tenths. So not 10s, but tenths here when something has been split up into 10 parts. And these are the hundredths. There we go. So 472 hundredths. Well, 100 hundredths means 1 whole because it's a complete fraction. So 400 hundredths gives me 4 wholes. So that deals with that part. And then we've got 72 hundredths. Well, we can't fit 72 in 1 column, so we would just put them over 2 columns instead. 72 hundredths. And we know then that 70 hundredths is the same as 7 tenths as well. So that would be 4.72. How do we know that? Well, the 400 means that we've got 4 full fractions. 400 hundredths is 4 wholes. Imagine it's a pizza. You've got 4 complete pizzas. Then you've got 72 hundredths or 7 tenths, because that's the tenths column, and that one would be the hundredths column. For number 18, another way to cheat. I've got 5 times 9. So 5 times 9 is 45, and then I can put that 0 back on. Another way to do that one will be 10 times 90, which is 900. 10 times 90. So you could just throw that 0 on the end there, and then you would divide it by 2. Because 10 times 90 is double what we need. We half it to get back to an answer that works. On to question 19. So children often struggle with these questions because they think they have to do it in order. What the children should be trying to do here is multiply these numbers in an order which makes their questions or their number sentences much easier. So if I did 7 times 6 times 5 in order, well, 7 times 6 is 42, and the children might not even know that. And I have to do 42 times 5, which is a tricky one, because you can't do it in your head. You'd have to set it up as a column multiplication. But what you could do instead is look to see, can I do a really easy multiplication there? And when I say easy, it's usually a number that ends up with a 0 on the end, because then I can cheat a little bit like I did earlier on. So 5 times 7 is 35. That's no use to me. But what about 5 times 6? Well, 5 times 6 or 6 times 5 is 30. And then if I do 7 times 30, I can use some of the cheats that I used earlier on by ignoring that 0 and doing 7 times 3 is 21, putting that 0 back on, and I'd get my answer of 210. No matter which way around you do these ones, you'll get the same answer. So do the one which is quickest and easiest. For number 20, we've got a column addition question. So I'll set that one up. But before I do, there is an easy shortcut that we can do here. And there's a few ways to do it. So you could either ignore that 3 completely and do 5,573 plus 2,000, get your answer, which would be 7,573, and then you'd add the 3 on that you ignored earlier on. Or what you can do, which is my favorite way of doing it, you can actually throw that 3 ones over here to make it, instead of 3 ones, you'd make it 6 ones. We've already compensated, so then your answer would just be 5,576 plus 2,000, because that would change to 2,000 there, which would give me 7,576. Now, most children will still set that up as a column addition, so let's have a look at how that would work. So 2,003, and then 5,573. If I'm adding those ones together, I always start in the ones column, and I just need to be wary if the digits go over 9, because if they do, I need to carry some over to the next column. 3 add 3 is 6, dead easy. 7 add 0, 5 add 0, and 5 add 2. Same answer, but a much quicker way to do it without column addition. Sorry. Now this one is column subtraction. Now again, I think a lot of the children will still just set this up as a column subtraction, and they can do that to check if they want to. But what they should realize here is that 321 is incredibly close to 329. So ignoring the 3's, I'm just doing 29, take away 21. The best way to do that one is just to count up from 21 to 29 to get your answer there of 8. But let's show it in the way that they've probably worked it out. Just get rid of this line here. Need a bit more space. Okay, so 9 take away 1 is 8. So again, we're in the ones column to start off with. And then in the tens column, I've got 2 take away 2. And in the hundreds column, I've got 3 take away 3. 8 is our answer. 22 then, we've got a slightly more confusing question. 1,507 take away 1,274. So a much more tricky question to cheat with, or no real shortcuts. So let's set that one up as we would do. 1,507, 1,274. So with any subtraction question, we start in the ones column, and we always have to ask ourselves, do I have enough? If I've got 7 in the ones column at the top, can I take 4 from it? Well, yes, I can. In the tens column, I've got a 0. Can I take 7 from 0? Well, I know I can't. So I'm going to have to do a bit of stealing. So I steal from a next door neighbor. I steal 100 and plop it next door. So now I've got 10 take away 7, which does work. And that gives me a 3. So now I've got 4 take away 2, which I can do very easily. And I've got 1 take away 1. So my answer is 233. For number 23, I've got 47 times 8. So I tell the children in here to set it up exactly as I do if they're getting it wrong. If they're not, they don't have to do all this extra stuff. That's fine, because they're showing that they understand it. But if they're getting this wrong every week, then they need to be shown exactly what I'm doing here. So set up as that, and then we do the bottom one times the top one, and I write that down so I can make sure I'm seeing that I'm doing everything properly. And then the bottom one times the top 10, which is 8 times 4. Get rid of those. There we go. So 8 times 7 is 56. If the children don't know that, then they can count in their 7s or their 8s, or they can do 8 times 5 and 8 times 2. 8 times 5 is 40, 8 times 2 is 16, and add them together. The next one is 8 times 4. That's 32. They could go 8 times 5 and then take away an 8. Whatever gets them there. So now I'm going to put them in the actual question. So there's 2 ways to do it. Either put the digit on the end in the column we're working in, and the other one nice and small in the next one, ready to add. Or we just write it as 56 left to right with a little 5 and a big 6. Next then, we've got 8 times 4 is 32, but remember, we've got something down here that we need to add on before we start doing that one, which I've just got rid of. Back. So 8 times 4 is 32, and then add 5 to it gives me 37, and I should see that working out on that question. So 37 would finish that one off as 376. On to question 24 then. I've got 777 times 9. Same setup, 7, 7, 7, and I'm timesing it by 9. So if the children know what 7 times 9 is here, and they know what all the answers are, and all they've got to work out is what's being carried between each one. So 9 times 7, 9 times 7, and 9 times 7. Ask them to show you the finger trick. They'll be able to show you how to work out any 9 times table like that one. Or they could do 9 times 5 and 9 times 2 to add it together, which will give them 56 for our answer. So all of these are, oh no, 63 there, sorry. All of these being the same answer. All then we need to figure out is what these look like in the actual question when we are adding them up. So the first one's nice and easy. I've just put a 6 and a 3. The second one, I need to add something to it because it's waiting there to be added. So I need to do 63 plus 6 gives me 69. And that can be put in the same way. 6 and a 9. Some children like to cross them out to show that they've added them. And the last one is 63 plus 6 again, which again is 69. So my answer there would be 6,993. On question 25, I've got 600 divided by 4. Now there's a nice quick way to do this because divided by 4 is the same as dividing by 2 and then dividing by 2. So we can actually half it and half it. So half of 600 is 300. And then half of that again is 150. So it's a nice quick way, there's a little shortcut to do that one. But what most children would have done is set it up as a bus stop or a short division. So 600. And then with a list of 4s, because that's the number on the outside, that's what we're counting in. We're going to see how many times 4, 8, 12, 16, 20, how many times the number digit on the outside goes into each digit on the inside. So 20, 24, 28, 32, and we'll see if we need any more. So let's go for a red here. So first of all, I'm asking how many times does 4 go into 6? Well, it's not in my list, so it doesn't go in exactly. So I need to put it in my list. There it is. So the amount of times it goes into the multiple above that line is how many times 4 goes into 6. So it goes in once, and then there's some left over. So I need to carry something over here. So 4s into 6 goes once, but from 4 to 6, there's 2 between those, 2 left over. Now I'm doing 4s into 20. 1, 2, 3, 4, 5, and that's in my list, nice and easy. And then 4s into 0, well, it doesn't go at all. So you'll see I've got the same answer as what I did before, but it's just a different way to get there. And this one then, there's not some great shortcut to this one, so I just have to set it up as I just have. So 8, and then a 4, a 1, and a 6, make that a little bit larger. Then I have a list of my 8s here. So again, if the children don't know their 8s, they've got their fingers, or they can get up to something where they know it, and then just count from there. So a good way of doing it, if you're going quite high, would be do 8 times 5 and then count from 40 onwards. But let's see if that's enough. So let's choose my colour here. So first of all, 8 into 4. Well, 8's bigger than 4, so it doesn't go in at all. So I need to show that, and I need to carry over all that I've not used, and which is the full 4. Now I'm doing 8 into 41. So 41 would fit into my list here. So how many times has it gone in? Well, it's the multiple above that line. 1, 2, 3, 4, 5 times. So it's fitting 5 times, and then whatever's left over, I carry over to the next digit. So 40 to 41 is 1. There we go. So now 8 into 16, well, that one is second in my list. Dead easy. And my final question is 1.5 times 3. So something that the children struggle with, but let me show you the way that I teach them in here, and we'll make it really clear. So I'm going to colour this. So I've got 2 halves of this question that we're looking into. So the first half then, if I cover that completely, is 1 times 3. That is dead easy. All the children know what 1 times 3 is. The second part, though, is a little bit more complicated. That is half times 3. So half times 3. But the children know that when we're halving something, or when we've got a fraction and a multiplication sign, we can use the word of instead. So half of 3 or half times 3. Well, it's been on the board since the very first day of the year. The children know that half of 30 is 15. So making that 10 times smaller, they should know that half of 3 is 1.5. When we're putting these two numbers together, we should recognize that both of these blue digits are 1s. So 3 add 1 is 4. And then I just put that 0.5 on the end there for my answer. Thank you very much for watching. You know where I am if you need any help. Have a nice evening.